the paper on distinguishing factors between traffic crash, white spots and black spots using classification and regression.
Sorry, Dr. Onib. There is one of the speaker, I think, from Asia. He is requesting the access. So maybe we will get now another speaker after you. So go ahead, please. Go ahead. After you, there is another speaker coming.
I was the first presenter anyways. So yeah, no problem. Okay, so my colleague Dr. Khalid Asi, who is from King Fahd University of Petroleum and Minerals, was a co-author with me on this paper. And I'm a PhD from King Fahd University of Petroleum and Minerals. My area is transportation planning. Currently, I'm working as an assistant professor in the Department of Civil Engineering, University of Bahrain. These are the contents of my presentation. I will give you a brief introduction about the topic, then aims and objectives of the study, then some things from the literature, study parameters which we have used. I will present the model and the results and the conclusions. So why this topic is important? Because it relates with traffic crashes, and traffic crashes have experienced a rising trend in the recent past, and it has been continuing. So according to World Health Organization, more than 1.35 million people die every year because of traffic crashes. And in addition to that, we have more than 50 million who are being injured because of these crashes. And it is a leading cause of death for children and young adults. So it's an alarming situation for these age categories. And they have predicted, if the current situation continues, that by 2030, it will become the 7th leading cause of death for all age groups. Okay, and these crashes are highly correlated with geometric features of the road. For example, lane width, shoulder width, and type of shoulder, and the median width. So what are black spots? Black spots are locations along the highways which have higher crash frequencies as compared to other sites. And different countries have their own criteria as for the identification of the black spots. But whichever country you are in, whichever procedure you are following, the first step in reduction of traffic crashes or highway safety improvement is the identification of the black spots. So it's a very important and the primary part of highway safety management process. Most of the black spots have been found to be geometrically deficient. Okay, so this is one common parameter which we have found whenever they are talking about black spots. So how to identify black spots? They have used many methods which are based upon statistics, and I will show you some of them later on as well. Now, in comparison to black spots, there has been a new term which has been coined as white spots. So what are white spots? According to European Union Road Federation, these are the spots or segments where no fatal crashes has happened in the last 5 years. So we term them as white spots. So these particular segments have not been paid much attention up till now in the literature. So this is why we have incorporated it in our research, so that we can generate more models and we can show how we can utilize this concept in highway safety management. So the main aim of the study is to use cart analysis to identify features which distinguish between black and white spots. Then on the basis of these features, we are trying to make comparison between white spots and black spots so that we know which geometric features are the main distinguishing features between them. And then to utilize this comparison in further improving the methods of identifying the black spots. Because obviously, in the end, the safety measures have to be taken on black spots. So from the literature, we have found that 3 main features have been rigorously researched related to the geometry of the road. This is lane width, shoulders, and medians. So in the context of lane width, narrow lanes increase the frequency of crashes. Okay, this has been shown very widely, and this is why it has become the prime feature in the highway capacity analysis as well. Shoulders, related to shoulders, there are varying findings. The first finding is that if you decrease the width of the shoulders which we normally call in Bahrain as the yellow line, okay, so that is the shoulder. So when you decrease the width of the shoulder, it may decrease accident frequency, but it may increase severity, okay. And again, these findings are from some studies which are done in different countries, okay. So in new settings they may change. Then median, in the context of median, two things are important: the type of median and the size of the median. Usually size of the median decreases the frequency of the crashes. If you increase the size of the median, crash frequency would decrease. And the type, the median can be just a line between the two lanes, or it can be with a barrier, or it can be with a curb. Usually hard medians, like something with a barrier, also which is totally separating both directions, is considered to be more effective in reducing the crash frequency. Okay, the black spot identification methods which have been used previously are these. The first 1, 2, 3, 4, 5, and yeah, these the first 5 methods are what are included in the Highway Safety Manual, which is adopted by Federal Highway Administration Authority of USA. So they are very commonly used. Okay, crash frequency, that is number of crashes per year; crash rate, calculating crashes per number of people per vehicle. Okay, EPDO stands for equivalent property damage only accidents. So you convert all the accidents into their value. And then EB stands for empirical based method. Okay, so you can apply to total frequency or only severe crashes frequency. Then some other researchers have also done for simple ranking methods and confidence interval methods. Okay, and then they have also applied empirical based with some variations as well. But this one thing which was found common in all the studies is the efficiency or the effectiveness of empirical based method in improving the crash in identifying the black spots. Now, one thing which is common between empirical based method and the CART analysis which we are using in this study is the method of probability. Okay, so these two methods, CART and empirical based method, are probabilistic method. Now, CART on one hand is termed as an artificial intelligence based technique. So Afghari et al. Found that if you are using artificial intelligence technique, so they use latent class model with multiple risk process to identify black spots, and they found it to be very efficient. So that's why we thought, why not apply some other method which may suit identification of or the distinguishing between white spots and black spots. So that's why we have come to the selection of CART analysis. Okay. So our study area was mainly Bahrain. We selected few highways from Bahrain, and according to General Director of Traffic in 2017, they observed, or they recorded. This is the recorded data. So the actual data may be higher. They recorded 111,000 traffic crashes with a death rate of 8 per 100,000 capita. For a small country like Bahrain, we don't have population even to up to 2 million. These figures are very significant. Okay, so the highways which we selected for our study was Sheikh Khalifa bin Salman Highway and Al Fateh Highway. Okay, these highways are very important related to the travel pattern of the country, and you can see I was trying to show the whole Bahrain, so the highways may not look bigger, but you can see the description over here. These highways are connecting very important areas of Bahrain. For example, diplomatic area and another arterials like Sheikh Isa bin Salman Highway. Sheikh Isa bin Salman Highway is connecting Saudi Arabia. Okay, so Al Fateh Highway again, it is connecting Manama, which is a capital of Bahrain, with the port area, industrial area. So these highways are very important, and they have seen, or they have experienced a lot of crashes in the study period. Okay, so our study period was from 2013 to 2017. Okay, and we collected the data from General Directorate of Traffic for these two highways, and we saw that these two highways during the study period had 312 crashes. Okay, and these are the points which were indicated as black spots on these highways. Okay, so obviously black spots are already identified by the authorities, okay, because they are studying these black spots. So these are node numbers, or node numbers which are given by the general director of traffic to the black spots. Okay, so this is our own coding, but if you go back to the figure, you will see that I have marked it with dots on the map. Okay, how do the general director of traffic comes up with the black spot? What method they are using? They are basically using the method of severity index. Okay, so how do we calculate severity index? You can see a simple linear equation here. So we are using x, y, and z. X refers to the number of fatal accidents. Y number refers to number of serious injury accidents, and Z refers to the property damage only accidents. Okay, so obviously fatal accidents have more weightage, injury accidents have comparatively lower weightage, and the least weightage is, or the lowest coefficient is for property damage accidents. So they have a criteria, a limiting value for severity index, which is around 35. So if a particular spot or a segment goes over this value, then they term that as a black spot. Okay, so you can see the severity index over here. Okay, so I think from this table, you can see which spots are black spots and which ones are white spots. We found more black spots, okay, on Sheikh Khalifa bin Salman Highway, because it's longer in length, okay, as compared to King Fateh Highway. Okay, and you can see when we say white spot, then the severity index is extremely low. Okay, and when we say black spot, the severity index is high. Okay. Okay, so as I said earlier, we applied card technique to develop the model to identify black spots and white spots, or to distinguish between black spots and white spots. Okay, so CART is part of the artificial intelligence family of the methods. Okay, and it is popular among researchers for classification problems. That is its main strength. But people have used it for prediction as well. But the main strength lies in the classification. Okay, and this is our problem. The problem which we have used it for in this study. Okay, this method is based upon finding out the optimum separation between two classes of variables, or between two classes of a variable, which can satisfy the given criteria, and it tries to separate the variables which are belonging to a particular category. Okay, so the main working of the model is to have an optimum separation of the independent variables according to the classes of the dependent variable. Okay, you can find more details in the paper and online. Okay, this is the CART model which we developed for our study. Okay, overall the percentage of black spots was 35. Okay, so there is for any segment, there's a 35% chance on these two highways. There's a 35% chance that it could be a black spot. Okay, and then if you go further, then you will see that if the speed limit is 110 kilometers per hour, then the chances of black spots being a black spot raises up to 46%. Similarly, if the speed limit is lower, but the number of lanes are less than 3, then the chances of being a black spot, and the ADT is also less. Okay, then the chance of having a black spot is up to 50%. Okay, the best situation is lower speed limit, low number of lanes, and I think there's a mistake here. This should be higher. This should be higher. Okay, so this should be higher. So less than equal to this value, then we have 0%, and more than this value. So if the ADT is between this range, which is 140,000 and 101,000, then you have 0% chance of having a black spot. Okay, if ADT, which is the average annual daily traffic, is in this range, you have low number of lanes, low speed limit, you have 0 chance of being a black spot. So that segment was found to be on these highways to be a white spot in all the cases. Okay, similarly, if you have a value which is more than this, but the lane width, then the lane width plays a part here. Okay, if the value is more than this value, then the lane width plays a part here, So still it's less than this value up to this value, but then the lane width plays a part. If the lane width is lower, then the chance of being a black spot is higher, and this is also confirmed with the literature. Okay, where narrow lanes increase the chances of crashes. Okay, so the main the most important feature is the speed limit. Okay, higher speed limits tend to increase the chances of the segment becoming a black spot, and vice versa. Okay, and then the other important feature is the AADT. Now, why I'm saying speed limit is more important? Because the node of the speed limit is higher up in the tree. So when a node or when a particular variable shows higher up in the tree, then it has more importance as compared to other variables. Okay. Similarly, if a node is appearing, if a factor is appearing more than one time in the tree, that also shows its importance. So that is AADT. So the two important parameters are speed limit and AADT. Okay. And obviously these are linked with the design of the road. With more AADT, the design of the road will be higher, the lane width will be higher, number of lanes will be higher, and so on and so forth. Now, one important thing which you can see from the tree are the optimum values of the parameters, which are distinguishing between white spots and black spots. So if the value goes, so you can see the limiting value for speed limit is 110. You can see the range of AADT is between 140,000 and 101,000. Okay, you can see the lane width, the limiting value of the lane width is 3.7 meters. So this is another important feature of CART model, that you can know the optimum values without doing any further analysis. These are the things which I've already discussed with the graph here. Okay, so in conclusion, from our study, we found that the speed limit is more than 100 kilometers per hour. You have more chance of becoming a black spot, irrespective of any other parameter. Okay, increasing number of lanes and lane widths reduces the probability for a segment to be a black spot. Segments with lesser capacity, so they have less speed limit and lower AADT, and they have lower number of lanes as well. They have comparatively a higher probability of becoming a black spot. Okay, and the reason could be that when the traffic volume is lower and so on, driver feel less cautious on these segments. Okay, so when you are moving over the segment which has lower capacity, so it is facing low number of cars, then you tend to go at higher speed. You tend to become careless, and you may have seen it even on local streets. A street outside your house, sometimes you see drivers going at blinding speed, and the reason is that they assume that nobody will be on that street. So sometimes it generates carelessness. So this could be the reason of these segments becoming a black spot.